Good morning, everyone. Those who have joined already, we're just about to start the first day, half day in the series of the data carpentries as part of ARCHER2 training. I've got some trouble with my drivers for the webcam, so I'm not going to share my video. I hope that's all right. Hope I'll fix it for the future, but this will also save some bandwidth. Hopefully you can see the window, the LibreOffice window I'm using, the spreadsheet tool, so we can see a table of rows and columns. And before we get to load the data, let's briefly chat about kind of most common uses. So another poll on line 54, grab a line and if you use spreadsheets already, there's no prerequisites knowledge for this workshop, but if you use if you come across spreadsheets already, let's summarize a few tasks that we use spreadsheets for. While we do this, yeah, I'll briefly summarize again the kind of plan for this morning session. So we'll briefly look at good practices, formatting tables and spreadsheets, how to avoid common formatting mistakes, and also look at handling dates or the ambiguities with various date formats that we might come across. We might speak briefly about quality control. So spreadsheets are quite useful for data entry, and there are some ways to ensure validation on input, which can prevent errors further down the line. And we'll look at exporting data from spreadsheets to different formats that we can then use in other tools. So if you don't have spreadsheet software installed, you can at least follow along visually, or you might be able to access a cloud-based version that most institutions now provide, something like Office 365. I'll be using LibreOffice because it's freely available and open source. Okay. So from the poll, I've seen the many different usages. So entering raw data, this is one of the core use cases or the original use cases. But nowadays, the tools are very powerful. So people are saying they use it for Gantt charts, pivot tables, for analysis, for filtering, organizing data. So yeah, these are all tasks. Also creating graphs and tables. But we also argue that those tasks are often better done using other tools programmatically. And hopefully it will be clear throughout the session why we think this and how we go about this. So we will not look at pivot tables or this plotting functionalities here. We'll rather look at what issues can we encounter, sometimes how we have to fix them, and why it's a good idea to move to a more programmatic way. So as you have all used a spreadsheet to some extent, does someone remember any frustrating situation with a spreadsheet? Or potential issue you would like to share? Feel free to unmute if you want. If not, I'll mention one story that was in the media a while ago, where a research group in the US had to retract a few papers from such journals, such Science or Nature, like very respectable journals, because of an issue that happened during processing in a spreadsheet, and it was difficult to track it down because of the way how tracking is not very well implemented in spreadsheet software. So often it's difficult to have reproducible outcomes. Are there any other issues that come to mind when you think of spreadsheets? Yes, so sometimes applying a function to part of the data, such as sorting by column, and only part of the data gets sorted and then it gets mixed up. And often the spreadsheet software will try to be clever and guess what you want to do, and this might not be what you intended to do. And we'll see a few examples of those as well. So let's look at some of those examples. First, we start by downloading the data file. If you click on the link, it should come to your downloads folder. And then I suggest one first principle is to not work on the raw data and rather work on a copy. So if you copy that Excel spreadsheet into a safe location where we'll use and work on it, and then you can either open it by double-clicking the file itself or by using the file menu, file, open. So find, maybe it's on downloads. For me, I moved it over to another file already. For me, it's under this data subfolder under my working directory. And that's a massive file, subset of the experimental data from the study I mentioned of rodents in Arizona desert. And scientists tracked over time the species that were in different plots, and then some plots they restricted access to only certain species and so on. So we can see sex of the species, plot ID, weight. By the way, let me know if I should increase the font size. So another good point that came up in the chat is data consistency, that sometimes data might be read in as a different type as text, but it's representing a date or currency. Oh, okay, interesting. Let me reshare again. about now? Hopefully this works. Okay, we can see the structure. It has some tables, some data points, some tabs of different formats. Okay, great. So I hope everyone was able to load the data, so we can have a quick look around and collect any issues you see with this data set. So let's gather this in the shared doc. We will be on line 63 and below. So let's spend a few minutes on this. Please add some of the points. If you find any issues with this data set, and we'll discuss some of them. We will not cover all the issues in detail and not all the solutions, but the materials will be available afterwards. So I'd encourage you also to explore some of the bits we won't cover in your own time. So let's have at least one point each. This way we'll have a few points to discussion. Also, if you don't want to type, feel free to unmute and mention it. So consider both formatting, layout, anything that will prevent reproducible analysis. Okay, let's spend 1 more minute on gathering. Maybe you'll find anything else, so feel free to look around also in the other tab. Just to confirm that the sharing works, if I switch tabs, you can see this in your at your end. Is it correct? So now I'm looking at the Dates tab.
It's still in the 2013 tab.
Same for me.
Sorry?
As I can't see between the tabs.
Okay, let me try reshare the whole screen perhaps. Okay, let's try that. It's not being reflected in, okay, let's talk about a few points. Hopefully you've got a known copy of the data. So you could refer to the tabs on your own screen in that way. So I'll pick up some of the points you've shared. So I'll be in the other pad for now. So missing data, separate blocks instead of species of adding column to separate separator. Yes, so that's a good point. We don't want to have spaces in our names for column names, for example. And ideally, we also want a column. So we want a tidy data format. This means we want each feature to be a separate column or each variable in our dataset, and then each measurement or observation to be a row. A value, a cell should contain only a single value. So this comes in where units, for example, appear as part of the value. That makes it more difficult for further analysis because this is then treated, the cell is treated as text and might need to be cleaned up first. So we would need to remove the unit, and to convert it to numerical value. Scales might not be calibrated. Okay, G, we have seen G again. Do you want to unmute and elaborate a bit on where do you see the issue about the scales? Ah, I see what you mean. Yeah, this is in column P in 2013 data set. So there are comments in the cell where the value also has some textual comment in it. Yeah. So this makes so if we apply some functionality for analysis, it might not be able to deal with the textual comments. The way how missing data is treated is important. Sometimes people use numerical values to encode the data is missing, for example, -999 or something like this, but this might have consequences when applying analysis functions. Okay. Let me share another screen. So hopefully you can see the browser. This is where the lesson materials are located. So if you go to Carpentry.org, so I will briefly mention a few other points. So keeping track might be a challenge in the spreadsheet setting. That's why we recommend to keep some sort of README file in a textual format to keep this analysis steps documented. At least this way we could manually rerun it, which is still tedious, but at least it would be consistent and it would not be only relying on our memory. Even for our future self, it would be nice to have the steps documented. Additionally, there is a pointer to Git lesson. This is part of software carpentry, and we can't cover it now, but it's recommended to use version control to keep these recipes as well, to track versions of those. So here are a few other examples of issues. For instance, when species and sex are encoded in the same column, this will make it more difficult to filter like by one of them. So instead, we should keep the data tidy so that we'll have one variable in each column, like shown in this figure. Okay. So a few other problems. That I mentioned here, we're not going to go through all of them in detail. With a few comments. Also feel free to unmute and share any experience that you have. So using multiple tables in one, it makes it more difficult to apply analysis consistently. Also using references to other cells. So if cells change, the references might change and so on. Similarly, if we have multiple tabs open, if we go back to the file, So you could also see how across tabs the style is inconsistent. So maybe different people were collecting data and came up with a different format. So I wonder if you can you see if I now switch to the 2014 tab, or is it not reflected in the display?
No, I can't see it switch.
Okay. So if in your own file you switch, you could see it used a different style, that it got slightly different headings, and so it sorts by plot rather than by species compared to 2013 data set. Okay, let me try one other thing. So if I say entire screen, no change?
No, I still can't see it. I don't know if anyone else can or if it's just me.
Strange. Okay.
So which page are we looking at? Because I can see 2014.
Okay. If I switch now, I switch to 13. Still is not reflected in the view.
No, it's still on 2014.
Okay, let me try one more thing. Just restart the application. Okay, and try rejoin for a sec. Bear with me for a moment. Okay. Try again. Different screen, maybe. Yes, the notes are available. So they're on the Carpentry's website. Okay, let's see this way. Hmm. Yeah, apologies for this. Just recently got a new machine, so there's some snags still to sort out. Can you see the LibreOffice window? I'll go full screen. No.
No, nothing's changed. All I can see is your desktop.
Okay. So, Jeffrey, would you mind trying to share? Have you got an Excel spreadsheet around? Okay. Okay, yeah, let's try this at least for this part. So hopefully Open Refine will work because it's working in the browser, and it seems like the window manager is confused about which kind of pane to focus on. So if you could at the bottom there is like a purple arrows. If you click on that, it opens the kind of little context menu, and the share content menu is a little screen with an arrow on it. Okay, great. So let's open the copy. Okay, yeah, so if we switch to 2013, we can see how it's, yeah, we can see this. I can see the switch at least. That's good. Okay, so we can see we have a table which is headed as species by species. And then if we switch to 2014, we can see how it's by plot. So it's inconsistent and it makes analysis more difficult. Also, we can see something like using contextual information. such this gray color to provide extra information. So this suggests calibration was not working for those cells, so they probably should be excluded from the analysis. But if we only look at the data, the spreadsheet software will not take the color into account. So this is one of the other issues. So if we use multiple tabs and multiple tables, it's easy to introduce inconsistencies like this. And also if we don't keep the data in a tidy format. Sometimes people don't fill in zeros, but this is also an issue because then we don't know whether it's missing data point or whether it's zero or sort of whether there was no measurement or whether the measurement is empty or faulty or something like this. And such blank cells can be misrepresented by statistical functions. So we'd recommend that missing data is explicitly encoded in a consistent way. And another reason for this is that the software can't guess a suitable value in most cases. But we should probably avoid most of the values that are not well defined. So in some cases, NA might be a good value for not available, but it might also mean North America if you've got, let's say, a textual data set. So it needs to be also defined in metadata. Another point to take care of is to include metadata as a separate file, not in the data itself. So this keeps this, those concerns separate. So let's come back to the calibration issue. If we really wanted to make it a variable so that we can subset by it, then it would be advisable to create a new column and have a Boolean value, for example, yes, no, to indicate whether the value is calibrated for a particular observation. So this would require to introduce a new column. And that's why it's nice to also have plots and species, not headers of separate tables, but to have a single table where species is a column name and different values will then be recorded. So this might use slightly more memory, but in general, memory is fairly abundant nowadays. Are there any questions so far? Okay. So in terms of naming, best practice is to use self-describing names. It's not worth having a very cryptic name just to save few characters. Also, we have mentioned data format and use of special characters. Yeah, the notes will be available. You can access them from the ARCHER2 training page where you signed up, but also you can find them on the data carpentry lesson, and there is a link in the shared document at the top. Okay, in the interest of time, I'll quickly summarize. So that the key points here are to avoid using multiple tables within one spreadsheet and avoid using spreading data across multiple tabs, because then you need to encode references between tabs and the way different tools do it might not be consistent. It is suggested to record zeros as zeros and use appropriate null values to record missing data. It is also advisable not to use formatting to convey contextual information or to just make your spreadsheet look prettier in some way. Comments should be placed in a separate column. Also, units should be in a separate column, as well as we should keep the data tidy. This means one column per variable and one row per observation, and each cell contains only one value. So yeah, avoid using special characters and spaces in your data and in column names. And record your analysis steps and metadata in separate plain text files. To clarify, spreadsheet software Word are using binary format, so the proprietary format that can encode formatting inside intermixed with the data. This is generally less portable across systems and tools. That's why we suggest using text files wherever possible. And you might to use a separate text editor to edit text files. Something like Notepad on Windows or something like Kate on Linux. There are various versions, but look out for text editors. Are there any questions about formatting recommendations or issues? Something that hasn't been mentioned before that you would like to chat about? If not, let's move on to dates. So you can also see how dates might be read in ambiguous ways depending on how it's encoded. It's generally not a good idea to encode a date somehow using custom format. So if we switch to dates tab, we can see an example of a problematic way to encode dates and a particular issue that happened here. So this is let's say plot 3 data that was added in year 2015, but it belongs to the semantically to 2014 data set. And if you click into the cells of the date, you can see those are interpreted as 2015 because whoever was entering the data thought they would save some time and not add the year. So such accidents might happen quite easily in spreadsheets, and that's why it's worth paying attention to date formats and have a more strict guidelines how to enter data. And when entering data, to enforce data validation. So it's possible in spreadsheets to set data validations forms so that, for instance, it might not allow to have non-numeric or empty data for a cell. So for instance, in column 11, it's difficult to interpret what this row means. Sorry, yeah, there is a date, but all data is missing. Is it a data entry error or a measurement error? That's not clear from this. Any other issues you can see with dates? In particular, let's say US style dates versus European style dates. In the textual representation, if we switch months and days, so if we don't know whether it's UK, let's say, or US format, then this would become, the string itself, the textual representation will become ambiguous. And another issue has to do with how data is represented internally in the spreadsheet software. So often it will be represented as a number. Maybe as a number of days since the beginning of counting of that software, which in itself can be problematic when transferring to another software. Sorry. Okay. Let's do an exercise next. I'll share a link to the materials in the chat, but also in the, so the exercises in the call out box is, I'll also copy the exercise into the shared doc. So the idea is that instead of having date encoded in one column, we want to separate it into a column for year, a column for month, and a column for day. And the spreadsheet software usually provides some functions to do this. And those are accessible under this fx symbol, or often as an equal sign introduces the formula. So we will be working in this dates, in the dates tab, and in the shared doc we will be on line 80. So the hint is to use this year, month, and day functions. Can everyone see the description, either following the link or on line 80 and below in the shared doc. I'll copy paste it again. Okay, let's spend a few minutes on this. The hint is to use this year, month, and day functions. So let's say we introduce a new column header for the E column. This could be year. And then we can apply a function to another cell. So we could refer to the column A. Let's spend a couple of minutes on this. There's a question about date formats, being able to switch between the formats. If you click on a cell, then there is a sub-dialog to format cells, and there you can pick the format you would like to have. But it's still a fragile process because it's possible to maybe pick a few rows but miss one, and then you might end up with slightly different formats in different rows, things like this. So it's possible, and the software has a lot of configurability, but it still is a manual process, and as such, there's still some errors that might happen that way that are difficult to detect. But what we need to make sure is that the new columns are formatted as numbers and not as date, because we will have number of years, number of months, and number of days as separate columns. So no, Jeffrey, if you want to do it as an example for years, to add a new column at E, and so give it a title, years, and then for the value, we could So type equals. So this is how we kind of apply a function. So equal sign and then year, capital year. This will be the function name. And we need parentheses. Those are defining the argument of the function year. In parentheses, we refer to A3 and click that. There is this, probably it's working if you drag slightly larger the column to show the number. Let's see if it works. Yeah, so we might play around with formatting if we don't want, because it's always whole years, we don't want the decimal signs in it. But this is the idea. If you drag it below, then we should get the year for corresponding rows. And we can see it's not very interesting in this case, except for this fact that it shows us 2015. And it helps us detect the issue that we were expecting 2014 actually. And then we can change the formatting to suit our needs. But similarly, you could see how you can do this with the month and day function. So one portable way to encode date is this as number of maybe a year and a number of days in a year, for example, or also year, day, and month as separate components. This way we can also filter and subset and group by months, for example, if we want to look at difference by month instead of years, things like that. So in the materials, there's also another exercise. We don't have time for it, unfortunately, but it looks at minutes, hours, and seconds. So if you have more detailed timestamps, there are often functions in spreadsheet that allow us to also look at times in a reasonable way. But often it's challenging because, we can get dates and times in different formats from different subsets, and often we need to first convert it to some unambiguous format and to use it that way. Okay, so what we can do now, we can save this as a CSV text file and have a look what happens. So if we click kind of save as CSV, UTF-8, yes. So CSV stands for comma separated values. This might not be useful for data where comma is already used as a separator, maybe inside a number or somewhere else. There maybe tab separated values can be used. So if we save this and open in a text file in a text editor, oh right, yeah, we can see this that it was complaining that it contains multiple sheets, but we save active sheet. And it's nice that we got this message that we might lose some data if we save it in this way. Okay, and if we open this, let's open it again with Excel or with the spreadsheet tool that you've got. And let's see, do you see any issues or differences with the data? So we're going to text format, and then we've got a warning because only active sheet got saved. And then if we open it again, the CSV file was saved. We can see that the dates look slightly different. But this also might be not consistent across all the tools. So if you use LibreOffice, you might see different behavior compared to Excel. And it's only to be a brief warning that treating data requires a lot of care, and treating data as multiple pieces of data rather than one may make it more tractable. Okay. But this also shows the functionality of exporting data. We can see how we can get a text format data from an Excel file. And some tools don't read Excel files, but they can read text files in CSV or TSV format. Okay. Thanks for sharing, Jeffrey. I'll try to share the materials in the browser next. To briefly chat about the quality control. We're not gonna do it in the interest of time as an exercise, but I'll briefly look at the materials. To chat about it. Okay, so hopefully you can see the browser window. So quality control, this is when we enter data, we can use the quality assurance data validation functionality. Okay. So this is this data validation. If we go in your spreadsheet tool, if you go to data and data validation, for instance, it's possible to define a range for a cell, and the tool will complain if the data entered is not within that range. So this section describes the steps, how to do it. So if you end up using spreadsheets for data entry, be advised that there is some way to ensure some basic checks on the values. So this way you can at least avoid some typos. So don't you have a tab like data in Excel? I think this refers to Excel. So it's kind of a small icon. So you might need to select the cells or columns you want to validate. And then it will go through a few steps in that allows you to specify a range, for example, minimum and maximum value, or whether blanks are allowed or not. And then what should happen is then when you're typing into a cell, you should receive an error message if the value is outside the legal range. And there are some notes how to specify maybe a list of legal values. Are there any questions about this? Yeah, one kind of a quick trick is to sort things and look at sorted values for columns, because some not only outlier values but also some either missing values or wrong values, for example alphabetical values in the numerical data, they bubble up to top or the bottom if you sort in ascending or descending order. So this is a quick check. And conditional formatting is something might also be useful. This uses a numerical value, for example, to provide also color. We spoke that we shouldn't use colors, but for a quick check, this might be still useful in the sense that if you've got a non-numeric value, it will get no color at all. So this way you could scroll through a column. If there are bits that have no color at all, those represent some odd data points. So something to be used cautiously, but might be helpful. But we'll also see in the next section a better way to do it, to explore dates and look for missing values and also correct those. Okay. I'll stop sharing for now. Okay. We have also seen exporting to text files. One caveat that applies there is that sometimes different systems like Windows and Unix have different conventions for line endings, and this might make a difference when displaying data. So this is something also to keep in mind, that different platform might encode line ending differently, and you sometimes might see in your spreadsheet software some \r or some kind of odd characters appearing. Which might need to use some filters to get rid of those characters. Okay, as the last exercise, let's save, if you go back to your spreadsheet, to dates, let's go again through the steps to go to File, Save As, and now if you use CSV, let's use TSV, so tab separated values, as an output, and see how it's different from comma separated values. So as the last exercise of this section, we will be on line 90 in the shared document. So right, might need to use the export rather than save functionality. And let's have a poll at the end. Did it work or not? Okay, so this brings us to 11 o'clock. Let's take half an hour break. And yet, in some, so LibreOffice might be more tricky in this respect. Might need to go through its own ODT format to get to TSV files. Or might need to go through text for like plain text. Let's yeah. So probably text is then the good option in that case. Okay. Let's reconvene back at 11:30, and we'll continue with OpenRefine. We'll look at exploring and cleaning data using a tool. Once you're back, please also complete the poll whether you've got OpenRefine working. This might need installation of Java JDK, so hopefully you're able to follow the setup instructions. And I will check that sharing is working and might switch to another machine meanwhile. All right, see you 11:30. Hi everyone, welcome back. Hope you had a good break. I hope you can see my OpenRefine window. I'm clicking around and it changes. Okay. Great. Hope the font size is all right as well. And let's see, that's a poll in the shared document. There is a poll on line 103. I'll paste in the link again in case you're rejoining. So OpenRefine is a tool we will use for data cleaning in this section of the workshop. It is open source and it's hosted on GitHub, and the community releases it every now and then. So hopefully the install worked for you. I've seen a few pluses in the poll. So if you run it, you should be able to access it in the browser under this kind of local host, and the port that's specified by default is 3333. There are a few commands. You can increase the memory if your data size is large. Then it's useful to have the extra flag. When you start refine with -m, you can specify the megabytes of RAM to use. Okay, let's next poll at 110. You got the data, and we'll create a new project. So one of the principles of OpenRefine, it doesn't change the raw data, so it will work on a copy of the data, and it will allow us, like the unique selling point is the how powerful the undo redo functionality is in OpenRefine, and it allows us to extract the steps, the data cleaning steps, and apply them again, replay them. Okay, there's some issue with OpenRefine. Let's see if we can troubleshoot this quickly. Can you specify whether you're on Windows or Linux or Mac OS? So the release is on openrefine.org as an archive that needs to be unpacked. Okay, I see there's some trouble with OpenRefine. Let's have a look. Okay, so it's few hundred megabytes, so it might take a little bit. And then it needs to be unpacked. And in the directory, there is an executable. One issue that might come up is that it requires Java runtime environment or JDK. Okay, let's see. If you scroll down, there is a download section, and under download, there is OpenRefine releases. If you click on this and scroll all the way to the bottom, there is, not all the way to the bottom, sorry, all the way to the bottom of the 379 release, there is assets section. And you can see different files. So if you have Linux, then it's Linux, one is for Mac, one is for Windows, and one is for Windows with Java. Were you able to see that? Let's use also the dataset portal rodents with the number specified in the shared doc on line 109. Okay, let's spend another minute on getting the data in OpenRefine. If you've got the data, you can create a new project. If you go ahead a bit in the materials, what I mentioned about the memory bit, it's not strictly necessary to specify manually. In general, Refine will pick a sensible value. But if you find your data set is huge, like your real data set, if you want to apply it to a real data set that's very large, and you might notice that at some point Refine starts stuttering or like going slow, this might mean that it could use more memory than it got allocated by default. And you can specify it using the flag. And OpenRefine.org has a lot of recipes and detailed documentation. So I'd refer you to those once you start using the tool in more depth. For today, we'll only briefly look at creating a project, exploring data, changing some values, and exporting the data, and also looking at how to save the steps. Yes, there is a step. You need to extract the archive first, and then it should be a self-contained directory from which you can run. Yeah, in the past, OpenRefine had some issues performance-wise, but over the time, the community has worked also on performance issues, improving. So hopefully now it can handle larger data sets. Okay. So what is the motivation overall for using OpenRefine? We can chat about that while the installation is ongoing. So often we've got messy data and we need to clean it, and cleaning it manually is a fragile process, so we wouldn't recommend using spreadsheets to do this data wrangling tasks. And OpenRefine was created in response to this kind of need. It was created at Google, I believe, originally, but then it became an open source project, and it's a growing community of novice to expert users who applied in different settings. So it has this philosophy of not working on the raw data, and provides this very powerful undo redo functionality. So that allows us to undo or redo the changes, so we can reverse the changes, which is nice. So this way we can experiment with different analysis and changes. Okay, great. So it's itself a Java program that runs in the background, so that's why there's need for some extra setup. But it's modern in the way that it uses browser to display the data. So hopefully by the end of the session it will be clear that it's a powerful tool and can be very useful in cleaning data. Let's first look at creating a project. So we'll import a data set that I've suggested. So opening Refine, we will click on Create Project, and I encourage you to follow along. Let me know also if you still have trouble installing, and maybe Jeffrey could assist you further. So click on this computer and find the data set that we have downloaded. Okay. Let's use the one with SciName UUID in the name. There's also a simplified data set which we can use. But let's see if we can use the 5 megabyte data set. first we'll see this sort of screen showing us the preview of data, and we need to make sure that once we import that we so in the middle of the page we've got this, so comma separated values enabled, and then the tick box next to trim is not activated. The character encoding is UTF-8, and so you can see there's a lot of files that are supported. JSON files are the JavaScript object notation files, for example, and others, XML files, Excel files, but we'll go with this text file. And then we can go back, start over if we want to change something, or we can create a project. Okay, there's some issues still with Java. Paul, if you're using Windows, then there might be a refined version that comes bundled together with Java. On Linux or on Mac, you would need to install Java JDK using the package manager for the software, for the system you've got. So this should create the file. So let me know how many rows have you see in the shared doc. Do you see we are on line 117. So if you've got a different file, you might get a different number of rows. It's good to know this now. So if you use the simplified file, the small file, this 64 kilobyte one, that will have a different number of rows. So once we created a project, this will be a copy of our data, as OpenRefine doesn't work on the raw data. This helps avoid some accidents where some data is overwritten and then we lose data, which might be fairly painful. So next, let's have a look at how to explore data using something called facets. So I'm thinking this allows us to filter things. So okay, if we click on facet, so maybe let's go with species. If we click on facet, text facet, so there's some facets predefined. They can help us select, so we can see what kind of species are included. And this also gives us the counts, so we can have a quick overview. If we scroll to the side, we can also so go back and use the scientific name, text facet. And then we can see all expressions, and this gives us a clue. Those that only have one count, those are likely typos, right? So this way we can quickly see if there are any issues with our data set, maybe some awkward special characters. It's very useful as an overview. OpenRefine is also useful for small data sets. It's one person's small data set is another person's large data set. So it's whatever fits in your memory, you could say. So it's not cloud-based in the sense that it runs on your machine. So if you have a very powerful machine, you'll be able to handle very large data sets. Whereas on a kind of older notebook, it might struggle to deal with gigabytes already. Okay, what we can do also try sorting it by count or by name. This changes the display, and we can see how names group things that are alphabetically close, whilst by count we can see there's some empty ones, for example, and those that have small counts are usually typos in this data set. Okay, let's do an exercise next. But before we do this, let's have a quick look at this functionality of edit. So if we hover over a value, we also have the possibility to correct it straight away. So we could manually change it if it's a single value and apply, and then we could see one count will go up and so on. So we can collect data like this, correct data like this, using the edit functionality. But OpenRefine offers even better ways to do this, and we'll look at this in a moment. But for now, let's do an exercise. You mean this question mark symbol? I think this shows a non-printable character, a special character. So maybe it's an accent or something like this. Okay, let's do an exercise using faceting. Find out how many years are represented in the census, which years have the most and the least observations, and then check whether the column is formatted as number, date, or text. I'll paste the exercise also in the online 122. We're going to spend a few minutes on this exercise to use facets. And you can add the solutions. to the shared document. Okay, it seems like there's some agreement on the number of years. Yes, so there is a column called YR somewhere. Yeah, this suggests there are 26 distinct values. So those are the years used in the study. And we can sort by count. This way we will see the smallest and the largest count. So I did select this as text facet. So that's why it's sorted by as text by default. So, but there's also functionality called transforms. So we can create a numeric facet from a text-based facet. If we select this year column and then go to edit cells, common transforms, there are some suggestions, and one that we can do is to number. And we've got a message that some function was applied to the data. Also, the color has changed to green here. So now we can look at a numeric facet. This gives a different display, which may or may not be meaningful for your data. Okay, let's do another exercise. I'll add it to the shared document. So we'll look at the period, plot, and record ID columns for this exercise. And first, we need to transform it to numbers. And then the question is how does changing the format change the faceting display? and also whether all columns be transformed to numbers. And we'll skip the exercise after that is looking more in detail what happens to non-numeric values, but we need to consider that not all values can be transformed. Let's spend a few more minutes on this. Okay, the answers coming in. Yeah, I've shown how year looks like in the facet as a kind of histogram-like view. When something couldn't be transformed to a number, maybe plot ID wouldn't work in this case if we use the kind of unique identifier rather than numerical value. But plot, we could go faster. Let's check what the values are there. We got 24 values. So edit, transform, common transforms. And if we had a non-common transform, we could specify in more detail. And OpenRefine supports something called Refine Expression Language, or GREL. So you can write little chunks of code to specify more complex transforms rather than the common ones. But here, if we look at the number, we can see how many plots, like for each plot, I count as a quick overview. So it might be useful as a way to explore data. But we can also still look at the textual view which is also useful sometimes, especially if there are not too many different values. Are there any questions about faceting? So if we try turn something to number that's not, there's no clear way to turn it into a number, then we'll see this message, text transform on 0 cells. This means it was not performed, and then we can undo the previous step. And this is a nice undo redo functionality here, that we can undo a particular step. So we go back to a previous step, and this has been undone. Okay. Let me quickly check. Yeah, in the numerical, different set of functionalities is available. So it's a quick view, but we don't see the sort or edit in this view. Okay, let's have a look at record ID. We can check first the text, so they're all different values. And we can change this to numbers, but as someone mentioned, it wouldn't be meaningful to look at the graph because they would all have their own unique value, but it's only for the purpose of identification. Okay, but let's turn it into numerical nonetheless. So we can try use it for a different type of facet. The scatter plot facet. So against year or plot ID. So it gives us kind of quick visual representation of data, and it might be something you would expect or not based on how the data was generated, but it would be a way to check some relationship between some values. It will open up in a separate window. So these are the numerical facets were now included. That's why it had 3 dimensions, which might look a bit confusing. So we have seen how faceting can be used to explore our dataset and identify potential outliers or issues. We have seen how to transform data using common transforms like to numerical data, but we can also split data and manipulate data using cleaning steps and then undo, redo. So this was the reason why we didn't remove leading and trailing white spaces when importing, so we can do this manually as an example step. First, let's see. So let's suppose we want to work with the scientific name again. Just quickly check if we've got the correct data there. I don't know, maybe that's not the best example. Let's see. Let's look at the, okay, so the idea is that we can choose a column and then so edit it and split into several based on some definition. So for example, by separator. Scientific name might be not be the best suited for this, but I think we can use coordinates as an example. Okay, maybe it's only in the small data set. But let's assume plot ID had some meanings in the IDs. We could split it into several columns based on a different separator. And here, if we choose minus and let it be guessed, but not remove the column. So we could see that this string got exploded into multiple columns. We can see 5 based on the dash signs in the ID. So in this case, it's not a meaningful kind of column to look at, but it illustrates the principle of splitting by some delimiter. So we can split a column. For instance, we could split a year. If we had year, day, and month as a string, we could split it back into year, day, month, for example. And we can undo this last step. So this can be fairly useful. So let's go ahead, spend a minute on maybe removing a column and then navigating back to the undo redo menu and undoing that action. And let's also do an exercise. So the undo is this kind of history of applied commands here at the top left. And then undoing means sort of going back in history. so I've undone the previous step. So I've got some. Okay, as an exercise, let's stick to scientific name. We want to remove, we want to trim white spaces and then split it into two columns as a, those will be the genus and the species split into two via this edit column split. Yeah, and the trimming is a common transform, so it's sorry. It tells common transform, trim leading and trailing. Yeah, so apply this first and then split the column. Okay. And let me know in the shared doc how are you getting on. And then rename the columns. So, but retain the original columns for comparison. Yeah, and in some workshops in the past, we had people becoming a bit emotional, realizing this tool exists and something they have done manually over laborious many steps could be done in this kind of automated, quick fashion. So it's worth knowing and worth sharing this knowledge. So we're only scratching the surface, of course, today of this tool, but hopefully it will encourage you to add it to your tool set and use it in the future on the data sets and share it with colleagues and engage with the community and see what other functionalities there is in the documentation and the recipes and so on. Could I ask you to drop a plus at line 157 to indicate you've done this step? Cheers. Are there any questions about this part? So if we apply common transform trim, we can see how a few cells got changed. And then if we split here, split into several based on separator would be space, I guess. And we keep the column. we still kept the typos in. But we've got two different columns. Have you found a way to rename those? Edit column, rename, this should be a way to do it. Rename and remove is quite close, but because OpenRefine keeps track, if you remove something by mistake, you can undo the step easily. Oh, there's already a name like this. Okay, I'll be naughty with this one just to have it. But this should be a more meaningful name. There's another chat question. Sorry. Feel free to unmute also and ask if you want. In terms of encoding for privacy, I'm not 100% sure about this one. But I also wouldn't be sure about Excel, how bulletproof their encoding is. So I think if you have sensitive data, you need to ensure you anonymize it and protect access correctly using the organizational procedures. Okay, one other functionality we can look at briefly is combining into columns. So we can join columns together. So for instance, if we pick the year again and sort of combine them together into one. Oh yeah, in terms of privacy, that it is running locally, yeah, but it doesn't really consider privacy specifically in any way. So if you've got user names and someone looks at your screen, they will see the names in the data or things like this. So still something that needs to be considered, but this tool is focused more on exploring data rather than kind of ensuring provenance or things like this. We can join columns. It's a reverse of splitting, so maybe month and days if we click them together and create a new column, call it date. And we can rearrange the order if we want to. Let's see what happens. So we've got here not an ideal representation of a date, but it demonstrates the idea. So now those are I joined together, but in a different order. So year first, and then we could see month and day. But because there are no delimiters, yeah, it's difficult to use this. So what we can do with this is to transform it to a date. That's also another common transform. So it was successful, and we got some different style, but it's unambiguous. And then we can look at a timeline facet for dates. Okay, there's some empty values, so it's not. We can zoom in onto some area. Yeah. Yes, it's possible to change the order in the menu, so you can drag the values in the join screen up and down. Join columns. I think here this can define the order if you drag things. I hope this answers the question. So, are there any questions about particular functionalities we might be able to single out and explore in more detail if there's interest? So we have seen in the scientific name near identical values. So we can cluster the text facet. This way we can use different functions. We can't really go into details about settings, but there is some functionality how to cluster together some values. And then if they're similar enough, we can decide to merge them into one and then define which one of those to choose as the one often. This is instead of manually collecting one by one, we can then use this clustering functionality to merge values together. So there are different functionalities, and we can't go into details how they're defined, but they're defined in the documentation. And this can be a powerful way to merge. So here it's already pre-selected. Let's merge this and see what happens. Merge and close, and then we see some things were not together, conjoined. And this way we can cluster and recluster and so on, and remerge and continue merging until we're happy with this. So clustering can help us fix errors in bulk, which is quite powerful functionality. Any questions about this? It's really quite a whirlwind tour of the functionalities. It doesn't change the column name unless we do it, but it changes the values that are less common, or the ones that we specified to be the new value. So merge means all values that are different become the same. as the value we suggest to merge under. I think it doesn't merge the cells that are far away based on the clustering. So there might be some typos that are considered different based on every distance metric supported. Then we might be able to code up our custom metric if we have many such values, or we would need to find a different way to, like maybe use a regular expression to rewrite the value first and then to cluster it together. So in terms of merging the cells, I think it changes the value of the cell only. It doesn't actually combine cells and counts, if that makes sense. But I'll need to double check in the documentation to be 100% sure. Okay, we've got half an hour left roughly. So it retains the same number of rows. Yes, it changes the value here so that now all the typos disappear and we have everything that had the similar name have the correct name. Yes. Okay, I'd suggest we have a quick look at filtering and sorting again. So how to use text filter to exclude or subset rows, and then we can sort tables by column or by multiple columns. So for instance, under scientific name, we can use a text filter to start selection, and then it will subset the data in the view based on what we're typing in, which can be useful to have to explore a subset of the data. This also shows how many matching rows there are out of total. So we can see how this doesn't mean this is the like all the data that's shown. If we say show 5, it will show 5, but it might match more than that is shown. So probably we shouldn't choose very high show value because this will also load the GUI more. So take a minute to play around with the filter bit. Select a column and then look at a couple of values. So you can also check the case sensitive box in the facet. Here, for example. And you can use a regular expression. I don't know, maybe something like this. Where star means any character. So this way we can have a quite fine grain of control what to select. Why got this selected? I think we can specify to start with a line. So yeah, but this still fulfills the kind of specification, and we can't really go into detail how regular expressions are working, but there is a way to specify character classes. So 0 or more of any type of character, for example, or maybe 0 or 1. But this way we can select something like, let's say, anyway, so I'd encourage you to explore regular expressions. This can be a powerful way to subset in a way that's not easily doable through the GUI itself. So we could think of filters and facets. How are they different? Faceting gives an overview of all the data currently selected, while filtering allows to select a subset of the data for further inspection and analysis. And then let's also have a quick look at sorting. We have seen sorting can be also useful to find blanks or errors. Let's sort by month as an exercise. And the question is, how can you ensure that months are in order? So there is the sort. If we sort by text, this will be alphanumeric order. So we can instead choose numbers and use smallest first, and then we'll get the months listed from January to December. It's not really a useful view. We can also sort reverse, or we can remove the sorting from here. So it's possible to sort by multiple columns. Any questions about sorting or filtering? Okay, there is more powerful functionality I'd like to mention without going into much detail, which is called reconciliation. So OpenRefine allows to reconcile scientific names based on a well-established taxonomy. This means it can look up, for example, in the species name in the Encyclopedia of Life. And this is the start reconciling part. And let's see if we can connect somewhere. So we need to pick a service here to connect. One second. Just get the battery plugged in. Okay, so it's possible to add some service. I don't know if this service is working, but let's try. If we add a service, if it's running, it might give us some taxonomy. And then we might be able to go through this whole process, which I'm not gonna do, but we can pick a column that we want, and then it will match against the online names provided. This can be another way to select correct values. Similar services might exist for country names or units and so on. So those can be used to enrich data as well. To reconcile, as I understand it, it means we compare our data set with a kind of ground truth taxonomy. And instead of picking manually the values, we can try use this machinery to pick the values based on community-defined dictionary, so to speak. I must say I haven't really tried using this on my own data, so I'm not sure exactly how it works. Okay. Yeah, there's this more sophisticated functionality. For instance, there's functionality to parse JSON style data. This is JavaScript object notation that we get often from API calls to web services. Oh, there's one example of reconciliation to match children's career aspirations. So something children provide, presumably in Annie, do you want to unmute and explain what the process entailed? So there is a standard UK job kind of occupational classification, codes, and then those could be compared against each other, for example. So it doesn't necessarily mean one is kind of the golden standard, but often it is provided by some external service. Okay. Yeah, so this JSON notation, as shown here, can be fairly involved, and then we can extract parts of the object and make it into a new column in our dataset and so on. So this is something OpenRefine can do, and I'd refer you to the documentation to check the details on how to do this. One last thing we should look at is exporting the cleaning steps and the data. So if we go to undo redo, there's also this extract and apply buttons. If we click on extract, we can see all the steps got transferred into also this JSON style notation, encoding all the steps. And then when we click export, this will give us the history. So this means we can send it to someone else to recreate our cleaning steps at their end. So this is a way to share kind of reproducible procedures. And at the other end, if we receive this JSON, we could instead apply, and we could paste that JSON into this and then perform the operation, and it would run through the steps. So I leave this as a homework to sort of start a new empty project and apply the JSON we just saved by pasting it into this window. But this is really also where power comes from, to be able to save the steps. And this means we can apply it to multiple data sets, the same steps. We don't need to, for every data set, open data set, click. We can automate this using OpenRefine functionality and this expression language. Last but not least, let's have a look at actually saving data itself rather than the cleaning steps. So this is what we can do through this export menu. And here we can find both tab separated and com separated values, but also other formats. Or maybe we can also write to database. Or let's see if we choose export, we can archive to export to archive as well. So we can save it to an archive. That's probably the most memory efficient way to store it. Will be compressed. It will end up as a tar.gz project. So this will be compressed, and but this will contain the whole project. if you save it and you open it, you can see that it contains some subfolders inside. One is the history, one is metadata, one is data zip inside that archive. This is how Refine structures projects as subdirectories. Extraterrestrial aeronautical engineer. That's the code for spaceman, apparently. So, yeah, and to import the file, we can then browse and find that same file and open it. And then it will also have the history included. And we can continue through the steps and get the project reopened. Okay, I think it wants a new working directory path or something like this. Okay, I'm gonna click this away. But this is the idea. The export is for exporting, and open allows us to open existing either archive or file from locally available file or even from a remote URL. Okay, I think this completes this tour of OpenRefine. If you've used it in the past, hopefully you've seen refreshed some parts. If you have never used it, hopefully you were convinced that this tool offers some nice functionality that can help you work. So there's some more resources. I'll copy a link into the shared doc at the end. Also, so first of all, are there any questions or any functionalities you would like to have another look at? We've got a few more minutes, but I would also like you to add a one up, one down feedback for this session. Apologies again for the sharing troubles. I'll double check whether it's specific to my OpenOffice installation. But tomorrow we will use R and OpenStudio, so hopefully you have managed to install it. If not, I'm happy to stay on here for a bit longer if you want to try and install it now, so it will be ready tomorrow for this session. So it needs to install our language itself, and then RStudio is a graphical user interface we will use. But before that, yeah, please provide some feedback. So maybe let's call it one up, one down. So one thing to keep and one to improve for this part. Oops, sorry. I'll just create a few points. Of course, to improve is also useful, and hopefully we can improve between now and tomorrow. So tomorrow this will be introduction to R, the language, the data types, and kind of the RStudio features and data frames, loading data, and then in the day after we will cover filtering, sorting, and plotting in the more programmatic way. And hopefully by the end of the workshop, you would be empowered to explore R and programming topics in your own time and use existing libraries for your analysis, for plotting, and for data cleaning, data exploration. So yeah, the materials are also all available online on Data Carpentry's website, along with others. So if you're interested in version control, come back to the Software Carpentry's workshop that we run as part of ARCHER2 trainings and every now and then. But also other departments might run similar workshops to learn about version control. So I hope it was useful. Thanks for joining. Also, thanks to Jeffrey for helping out and also with the sharing. So I'll see you all tomorrow.
Hi, sorry, can I just ask where were the instructions for installing R?
1 second.
Sorry.
So there must be. So I'll paste it also the link to the ARCHER2 page. It's quite a few jumps, I think. So this is the overall page.
Okay.
And if you go at the bottom to the course materials, then to introduction to R, okay, it might not be linked from there. So R ecology lesson. There was a setup install R. Yeah. So it's R ecology lesson. There is preparations subsection of the first menu subpoint. So I'll paste the link. It's on line 185. So our ecology lesson. If you click on that and then install R in RStudio, it has a section for Windows, Mac, and Linux. If you click on that, it will open like a little bullet point list.
Yes, got it. And then do I need to install those packages as well?
Yes, so RStudio relies on R, and R relies on whatever it needs, like R base package. What is your operating system?
Mac OS.
Mac OS. So on the Mac OS, it suggests to use this CRAN, Comprehensive R Archive Network website to download it. And it also suggests this XQuartz.
Oh yeah, I have that already.
So it says if you double click on the downloaded file to install it, it should be added to the apps. So I'm not too familiar with Mac, but if you could try this and see if then RStudio for Mac OS, if you double click that, if it installs without errors.
Is this on the CRUN website?
It's on rstudio.com products, RStudio download. It's the 1, 2, 3, 4, 5th bullet point
Oh, yeah.
of the Mac OS.
Okay, can I just use that download link for R as well as RStudio?
If you've got R installed, I don't think you need to install it again, but it's worth checking the version that it's relatively recent. So
Yeah,
I
I'm
think
not
it
sure
needs
if
to be more recent than 3.3.
Okay, I'm not sure if I do have R installed.
Probably it's if you follow from the first bullet point, it would be safe to download the newest PKG file from CRAN and then double click that. If you've got Xquartz, that's fine. If you don't have it, maybe it's also useful. I think this is to have nice GUI elements on Mac, and then RStudio is the last step. Also, RStudio itself, I think, got some installation notes, which might also work out of the box.
Okay, all right.
Okay.
All right, thank you.
Yeah, I'll stick around for a few more minutes if you want to try and see if it completes. Other than that, thanks everyone for joining, and see you tomorrow. We'll start at 9:30, I believe. Yeah.